What did we, guys, what did we have yesterday? Aluminum and copper chloride? Or copper and aluminum? Aluminum and copper chloride, okay. All right. So aluminum, copper 2 chloride goes to copper and aluminum chloride, right? Could you please remind me of the amounts? Thank you. And it was 130. Thank you. Okay, so you already have this information. So now I'm going to show you how to solve using dimensional analysis. We have already done the traditional method, which finds limiting reagent first, then you calculate the theoretical yield. This way, we're going to be calculating the theoretical yield, and it will also tell us the limiting reagent at the same time. So you have this already down on your sheet. So you, right? You don't have to do this on a separate piece of paper. This is in the booklet. This is on the back side of one of the pages. You got a huge white space that yesterday you filled up with formulas. Now you can throw dimensional analysis on there too. Grams of copper in it. So which ratio has grams of copper in it? Yeah, so we're always going to start with the molar mass of the substance. Don't write this down yet. I'm going to start with the molar mass of the substance that we're looking for. So we'll do aluminum first. So we want to get rid of moles of copper. How do we get rid of moles of copper? What do we have to use? Mole ratio. So we've got 3 moles of copper for every 2 moles of aluminum used. Now we've got moles of aluminum. Stop writing it. We'll have time, I swear. Now we've got moles of aluminum. Got to get rid of them. What else has moles of aluminum? Molar mass of aluminum. Great, we've got rid of moles, but now we've got grams of aluminum. Now we multiply it by the mass of aluminum. And that will give us a number. So with your calculator, any number that's on top is going to be multiplied. Any number on the bottom is going to be divided. So, assuming all of our aluminum gets used up, we'll produce that much grams of copper. Now you repeat it for the other reactants. We want grams of copper, so we're going to again start with the molar mass of copper because it has grams of copper in it. So we've got moles of copper, got to get rid of moles of copper, so we're going to use our mole ratio. We've got moles of copper 2 chloride. Want to get rid of them? Use our molar mass of copper 2 chloride. Make sure that the number with the grams is on the bottom. Then multiply it by the mass of CuCl2. Multiply by every number on top, divide by every number on the bottom. Should be around 0.2410 grams of copper. So what you're going to do is you're going to end up comparing this number and this number. Which one is smaller? The bottom one. So then this becomes your theoretical yield, the maximum amount that you can make, and it came from your limiting reagent. So whatever is there is your limiting reagent. So this is just another way to determine the limiting reagent and your theoretical yield at the same time. So when you have a therefore statement, though, make sure that your final mass, your theoretical mass, is rounded to the proper number of significant digits. Any questions?
So in the first dimensional analysis step, were you trying to find just the mass of copper?
You're trying to find the mass of copper, but you have to do it for each reactant.
Okay.
So you're assuming aluminum gets used up, and then you're going to assume copper 2 chloride gets used up. You can't make more if you've run out of your limiting reagent. So the maximum mass, this is the tricky part here, the maximum mass will be the smallest amount. Because now all my copper 2 chloride is gone. I have none left. All got used up. So this is actually where the reaction stops. I would have to put more copper 2 chloride solution in if I want to make this a bigger mass. Any questions? Okay, turn the page. I think there's some questions. The amount of excess reagent you have to figure out how much is used. Right? You have to figure out how much of the aluminum got used up in order to figure out how much is left over. So instead of doing dimensional analysis to find the grams of copper, you would figure out the grams of the excess reagent. So we've already decided aluminum is our excess reagent. Correct? So 26.98 grams of aluminum for every 1 mole of aluminum. Right? If I do this, my last unit should be grams of aluminum. So what is my ratio of aluminum to copper 2 chloride?
2 and 3.
So I've just gotten rid of moles of aluminum, but now I'm stuck with moles of copper 2 chloride. But I know my molar mass of copper 2 chloride And I know that I had how much copper 2 chloride?
0.51 grams.
So the reason that I used copper 2 chloride is because I know it got all used up. So this is a way to figure out grams of aluminum used. So what is 26.98 times 2 times 0.51 divided by 3 divided by 134.45.
0.0683.
Anybody else get that number?
Yeah.
So that's how much aluminum got used up in this reaction by my limiting reagent. To figure out how much I have left over, I subtract that from the amount I started with. So if that's how much got used up,